Okay, let me change my camera. It's swapped to the other side, and that's going to look really annoying for all of you. There.
Yeah, it looks like it switched.
Yeah, okay, so I'm going to just go ahead and look over here. Okay, so I'm going to talk to you about some cool new features in Packer. This isn't so much of a tutorial as it's going to be sort of a tour of my personal favorites. But about me, I'm Megan, and I'm the engineering lead for Packer. So I work for HashiCorp. My GitHub handle is Swamp Dragons. That's relevant because I'm going to share a repo with you. This talk is going to have a lot of demos. It's a lot of features in the last year or so. And I've also slipped in a couple of features that are going to come out in the next release, which I'm really, really excited about, and I couldn't not share. So with this, I'm going to focus on features that I think are going to really improve the user experience for engineers who use Packer. And I'm also going to share some features that we've added recently that make Packer easier to integrate with other HashiCorp tools, because this is HashiTalks, and a lot of you use Packer in addition to a bunch of other HashiCorp tools in your HashiCorp toolbox. So if you want to follow along at home, go ahead and check this link out, my profile / cool new features demos, and you'll find most of the scripts that I'm going to be using in this talk, and the ones that are missing I will upload right after the talk. I just didn't quite get around to the last couple. So I guess without further ado, I'm going to start showing off some features that you may not know about. And first, we're going to talk about the variables section of the Packer template. So traditionally, you only had a few ways to pull variables into your Packer template. You could either hard code them like I'm showing here, or you could pull them in from the environment using the env template engine. Or you can make them blank and just force yourself to set them on the command line with a command line override when you call Packer. And you can get really far with all of these things, but any of these methods means that if you're getting your variables from some service like Consul or Vault, or if you're using a wrapping script, you have to ping that service, and then that wrapping script has to set the variable for you, which can add some overhead to your build. So two new template engines, which allow you to pull variables directly into the variables section of your Packer template using HashiCorp's Consul or Vault tools. So I'm going to dig briefly into these with an example and a demo for each. And we're going to start with the Consul KV store. Now, you probably shouldn't be storing really sensible variables in the Consul KV store. We'll talk about Vault later, but there are still useful things that Packer may want access to. So for example, if you're using Packer to build an image that'll be used to run a service, and we'll call that service my service, every time you update the service, you create a new image using Packer. And you don't want to have to change the Packer template by hand every single time the service is updated. So what you can do instead is you can ask Consul for the current version number of a service and use that version number to figure out what version of the service to install on Packer. Again, previously you might have been doing this with a Packer wrapper, but now you can do it in a template. So most of the magic is happening in the variables section, which I'm going to define here. I'm going to have a variable called service version, which I tell Packer to read from Consul's key value store at the path myservice/version. Now I'm going to define a null builder just to make this example and the example in my repo runnable for all of you. In real life, we'd be using a shell provisioner probably to download the file to our instance, but in this case, I'm just using shell local to echo the idea of a URL, basically. So we're going to take the variable defined in the variables section and then use it in the environment vars option on the shell local provisioner to pass that variable into the provisioner, and then just echo into an example URL using an inline script. So in this case, the idea would be that we're going to download the service from example.com, and its version number is part of the URL, that last part of the URL there. So in real time, let's see what this looks like. I was not brave enough to do this live. Consul agent dev, so we're just launching the Consul agent here. And now I'm going to be clicking over. I'm going to add my service version 1.0 to Consul by putting it into the KV store. Then I'm going to run my test build. And you can see the URL I'm echoing without any extra work from me has that version 1.0 in it. When I change version to 1.5, it changes what's echoed. And this is without changing the Packer template at all. All I've changed is what's inside of my Consul instance that I've spun up there. So again, you don't want to be using this for secrets. For secrets, as I'm sure you're all well aware, HashiCorp has this other tool. And so we also have an integration with the Vault key value engine. And that is a secure and versioned way of accessing sensitive information. And Packer can integrate with Vault to retrieve these secrets as long as you've got a Vault token and a Vault address defined in your environment. So knowing that we've got these defined in our environment, what's it look like in a real Packer template? As before, I'm using this integration inside the variables section. You can see that the template engine has three parts. There's the word Vault, the path to the key value pair inside of Vault, and the name of the key whose value you want to retrieve. Now, I'm going to share just a quick note here on the path to the secret. There are three parts here in my definition. You can see I've got the name of the secrets engine, which in this example and in all of the Vault docs, you'll see is just given the name secret. You can change it, but this is the default, so it's what I'm using in this example. And then I've written data, which you've got to have between the name of the engine and the name of your key. It's there because it's part of the API request for the version 2 of the Vault key value engine. And you need it in order for the API request to actually work properly. If you just have, in this example, secret/hello, it'll say there's nothing there. That's the pathing that you might use for the version 1 of the key value engine, which also works in Packer, and it's also documented on the Packer website, but I'm not demoing that. I'm demoing version 2. So then we've got the actual path to your key, which in this case is hello. So if that was confusing to you, then I recommend you go ahead and take a look at the Vault API documentation. Otherwise, we can roll with it and move forward. So let's move to the rest of the template, back to where we were. I'm going to define the same toy builder, the same null builder as we did for the Consul demo. And finally, I'm just going to use the shell local provisioner, only instead of, a tortured example with a web address, we're just going to echo it so that we know we got it okay. So what's this look like live? First, we've got to kick off the Vault server by calling Vault server dev. Then I need to add my Vault address and my Vault token to my environment. In real life, obviously, you wouldn't be just grabbing the root token from your Vault instance. In real life, you'd have created a special token just for Packer. But for the purposes of this example, and because this is a dev server, we're just going to pop the root token into the environment so that I can run this. Now I'm going to instantiate the key value store. Vault secrets enable KV. And then I'm going to add a secret to that KV store at the location that we talked about earlier, which is secret/hello. And then the key is foo, the value is world. Let's go ahead and run our Packer build now. Turn off verbose logging. Test Vault integration. And here you can see we've managed to print world successfully. And again, this script really is as simple as what I just showed you previously. It just is pulling that in from the variables. So that's not the end of Packer and Vault, because coming up in the next release, we have a new integration, which is the ability to use another tool in the Vault toolbox, which is the Vault AWS engine. Now, this is a totally different part of Vault than the key value engine, and its job is to generate one-time use credentials for Amazon Web Services. Instead of authenticating via environment variables or using an AWS config, which is what we normally do, now what we can do is tell Packer to ask Vault for a one-time use IAM user. You'll notice that this pattern isn't quite the same as the code we were looking at before, because this time the magic is happening in the builders section of the template rather than the variables one. Now, I've left out a lot of detail on the code here so that it would be visible on the slide, but you can find the full working example of this in the repo I linked earlier. It launches a T2 micro instance on Amazon, and all of the stuff that you need is there as long as you've got valid Amazon credentials that you're going to be giving to Vault. So, and you also have to have the Vault address and Vault token defined that we talked about earlier. So of the code that I did include in this slide, we've got the simple builder type definition, and then we've got the Vault AWS engine portion. And what that is an object that contains the name of the role that I want to ask Vault to use to generate my IAM user. In this case, that role's name is my role, which will be relevant during the demo because it has to match the name of a role that you've defined in Vault. If it doesn't match, it's not gonna work. Let me play the demo for you so that we can take a look at this. We've already got our Vault dev server launched. We've already got Vault address and Vault token in the environment. Now I'm enabling the Vault AWS secrets engine. And I'm going to add Amazon credentials to that secrets engine, which are used as the root credentials from which we're generating the other IAM users, which are going to be one-time use. Now that that's added, I need to create my role. And the role, just like in the example I showed you, and this is all the permissions that I think Packer might need in order to be able to run a build successfully. So now we're doing Packer build. This time I left the verbose logging on so that you can see that it's taking a few seconds for the authentication to actually pass. That's because Packer had to ask Vault to ask Amazon to generate credentials. Amazon gave us credentials, but Amazon's huge and eventually consistent, so it takes a little while for it to recognize the credentials that it just gave us. So we just spin there for about 15 seconds until Amazon says, oh yeah, okay, I did create these, you can use it, moving on. Having these secrets stored in Vault makes it easier not to have a paper trail. It makes it easier not to have to configure your environment in particularly special ways. But it's also good to make sure that you aren't accidentally logging secrets anywhere, particularly if you're passing secrets into Packer provisioners. And that's where this next feature I want to talk about comes in, which is a new-ish top-level section of Packer called the sensitive variables section. And it's here to make sure that you don't leak important things into the Packer logs. Let's just say Packer needs access to a super secret password. Instead of reading it in from Vault, for the clarity of this example, I'm just hard coding it to I love waffles. I should probably get some advice about more secure passwords or like use a password manager or something instead of using something so insecure, but you know, it's the truth and I'm living my truth. So we're gonna go with it. We may think, I don't want to accidentally print I love waffles into my logs or else it'll defeat the purpose. So let's tell Packer not to print this into the logs. We can do this by just adding the name of the variable. Note, I'm not putting its value. I'm just saying, hey, that thing's stored inside super secret password. Don't go blabbing that. We don't want that. Be on the lookout for it. Don't put it in the logs. This is important because we aren't forcing you to hard code anything. Now, it's time to define that beautiful null builder. And this time, we're just going to scream that super secret password into the void using the shell provisioner. This is important because what we're not doing, we're not actually printing this password on the remote system, so you'd think that it would never show up. But if you're using environment variables to set a sensitive variable, and you have verbose debug logging enabled, and you're storing that log in a log file, what's going to happen is that it logs all environments sent to the provisioner to help you debug to make sure that your variables are, you know, the right values. But that's not going to happen in the case where I've defined sensitive variables. It's going to redact anything that matches what you've told it not to print. So just to give you an idea of what this looks like in real life, first I'm going to run it without sensitive variables enabled, and then I'm going to run it with sensitive variables enabled. So you can see I've accidentally printed I love waffles into my debug logging as part of the command being sent to the remote guest. If I open up sensitive variables and go ahead and add that new top level feature and add super secret password and save the file, I can rerun this. And this time it's redacted and replaced with just the word sensitive inside of carets. This is going to really help improve security and paper trail when you use Packer. And the cool thing is that by giving Packer this information directly, you're allowing us to only redact the absolutely necessary stuff while still providing you as much detail as possible for debugging your builds. So that's the end of my tour of improvements to kind of the variables and security section of Packer. But there are a lot of other quality of life improvements that have come out recently. So we're going to start by talking about this brand new provisioner, the Debug Provisioner. This allows you to stop between specific provisioners and step through the build at particular points. So if you know you're always failing on a particular provisioner, you can throw in a breakpoint right before the failing script runs, SSH into your guest, and see what's going on. So here's an example. Essentially, instead of using the packer -- debug flag, which will stop between every single provisioner, but also between every single step of the build that's internal to Packer, like step launch instance or step configure SSH or step get me coffee, all you have to do is add the breakpoint provisioner to your file wherever you want to pause. So in this case, if I'm failing right before that second shell local provisioner, I can pop a breakpoint in between the two provisioners, and then it'll only pause there. I don't run this with the debug flag. I just add this provisioner. This is really nice for debugging really long builds that are definitely doing in another place. If you want to toggle the provisioner on and off, you can also do that just by disable equals true. You don't have to remove the whole provisioner and then re-find where to add it every time. You'll also notice that there's a note option, and this allows you to basically comment your provisioners, so it's easy to figure out where you're at in the build run. Okay, this breakpoint is the one I've set right before we modify SSHD, for example. So let's take a look at this breakpoint provisioner in action. First, I'm going to launch it with the breakpoint provisioner in and enabled. You can see it just pauses. It just waits for me to goof around. I can move windows, I can do whatever. When I hit enter, it continues. Now, when I open up that code and then modify the breakpoint with disable equals true, it'll still log that there was a breakpoint there, but it will not pause. It'll just continue straight through. You can see it says provisioner disabled, continuing. So that's the breakpoint provisioner. I really hope that it makes your lives just a little bit easier. I think it's going to be a lot of fun as debugging can ever be. The next thing we're going to talk about is shell local. I've been using it a ton during these demos because it's useful for illustrating simple concepts without needing to spin up an instance. But you've also all probably used it yourselves. It's among our most popular provisioners and post-processors. I'm not doing a demo for this one. This isn't going to be quite as exciting, but I just wanted to call out that we did a fair amount of work this year to really improve the flexibility and usability of the shell local provisioner and post-processor. Without getting too much into the code of it, the post-processor used to have a ton of features that that used to have a ton of features that the provisioner didn't have, and the provisioner had a ton of features that the post-processor didn't have. Now, this is obviously not ideal because it not only correctly implies that these two things were just a complete mess of copy-pasted code that had huge configuration drift and gotten out of sync with each other, but also because it was really confusing to our users which options were available when. So, for example, one of them would kind of work when you wanted to use it on Windows. You could kind of hack it. The other one you couldn't. One of them, you could set environment variables to pass variables into the provisioner. One of them didn't. Variable naming was inconsistent, or option naming was inconsistent because one of them used the word inline where the other used command. They were talking about the same thing, but the option was different. One of them allowed you to modify the invocation of bash, the shebang, and one of you didn't. So one of them was a lot more flexible than the other. And we didn't really originally put a ton of effort into fixing this for a really long time, even though shell local is super popular. And the reason for that is that for a huge number of shell local use cases, you can work around them with a good wrapper for Packer. And we felt like a good wrapper is a better solution than Packer acting as a naive pass-through for native commands. But that's many use cases, not all of them. We had a brief conversation last year about whether we wanted to deprecate shell local altogether, but the resounding community response was, to be polite, please don't do that. So instead we fixed them. I did some refactoring to bring the two back into feature parity with each other, but that refactor also brought a ton of flexibility to both the provisioner and the post-processor. For example, it turns out that a good handful of folks were using shell local for Windows builds, but it was really poorly supported and questionable as to whether it was going to work as expected. Now, from the box, shell local now assumes that Windows users want to use the command prompt. and it chooses reasonable defaults to enable that without extra customization. If you do want to customize, you're able to run PowerShell scripts by just adding customization to your environment variable format and your execute command. You can even run bash scripts on the Windows Linux subsystem if that's your jam. You just have to tweak the pathing rules a little bit and modify the execute command in your options. You can also define special formats for environment variables. You can even call Python scripts now, which you could probably do before, but we have it documented nicely on our website now, so it's more officially supported. All of this is to say that if you don't have a dedicated provisioner for the thing that you want to do, hopefully now Shell Local is as flexible and reliable as it needs to be in order to allow you to script up what you need. Again, I'm sorry I didn't make a demo for this. This is just a lot of hot air here, but even though it's not that exciting, I think it's a huge improvement worth mentioning. It's one that I'm giving in this talk, even though it's the one that doesn't have the demo. Another quality of life improvement we've made for some of you more advanced users is generated files. This is a feature for the file provisioner that people had been asking for a really long time. The file provisioner normally checks during the validate phase of Packer to make sure that any files you intend to upload to your instance are present on the build machine, and that we didn't make sure we would fail, or that we made sure we wouldn't fail deep into a build. And that would waste everyone's time just because a file is at the wrong path or because you made a typo when typing it in. So sometimes that's not what's going on. Sometimes in advanced use cases, you may generate a file as part of the build process during that Packer run. And in these cases, we had a really ugly workaround, a hack, and that was officially documented on our website because it was so common. But basically the hack was to hide the generated file inside of a directory and then point the file provisioner at the directory, uploading the entire directory rather than just a file. It's kind of an annoying workaround if you only have one file you want to upload. And it doesn't really add a whole lot of extra security to say, hey, there's a directory here. So it wasn't really super valuable. So we created this generated option. This tells Packer not to fail in validation just because it can't find a file on your local file system before you run your build. This allows you to create or download the file during an earlier provisioning step. We didn't add this sooner because of the fact that debugging pathing issues isn't fun for anyone after you've waited for a 2-hour build to run. So it's a bit of a foot gun. If you take this and you use it and you get in trouble, don't complain. But if you know what you're doing, please, by all means, have at it. I'm going to close out with another soon-to-be-released feature because I'm really excited that I can give this to you, and that's the brand new Vagrant Builder. This has been the single most thumbs-up issue on Packer's GitHub repo for years. There was a feature request put in years ago, and we've just not really gotten around to adding it. This is having the ability to build from a Vagrant box directly and then save to a Vagrant box directly, rather than having to extract the box to its VMDK or VMX or whatever. So now you can. It's new. It's coming out in a week. It may not work for all of your use cases, but for those of you who want to iterate on boxes, I think you're going to really like it. Again, I don't have demos for all of these. I'm going to give a demo for one of these at the end, but I'm just going to step through code samples for all of the different ways that we can source boxes now. This is a working example that pulls the official HashiCorp Ubuntu box from Vagrant Cloud and then saves it to a file named package.box in the directory precise-box. Okay, then there's also the ability to build from a box file that you've just got stored locally. This builder actually builds from the output of the previous build. And you'll notice that here I've set the teardown method to halt. By default, it's destroy. And this will just halt the VM so that then you can restart it and iterate on it and goof around with it in your own local environment however much you want. That allows you to basically build boxes you can play with no extra effort, or customize boxes to play with no extra effort. You can also build from a box that's already been added to your computer. So here we're building with a box named testbox packer. And as long as that box has been added to our environment with that name, Packer can build from it. And in that same vein, you can even, instead of setting a source box name, just use a global ID of a box in your environment, and Packer can launch VMs from that. So let me show you a demo here. The first thing that you're going to notice here is that I've got the local box file on my directory or on my file path, and I have to give it a checksum to say this is the one that you're expecting, just as if you were downloading it from anywhere else like a normal file. Now you'll notice that we're just running through steps that we're calling out to Vagrant directly. Packer isn't unpacking a Vagrant box and running it on some other builder. We're wrapping Vagrant itself and calling Vagrant so that Vagrant can do what it does best, which is manage the VM, and Packer can focus what it does best, which is provisioning. This does mean that if you want to open up a Vagrant box and then launch it with VMware or something, you're probably still going to be best served by a wrapper script. Another limitation we have here is with the artifact that we're going to be putting out at the end of the build. By default, we're calling Vagrant package, which is going to be creating the box. And what this Packer template is, because I haven't told it to skip that package, it's going to try to package it. But there are a fair number of Vagrant providers for which package isn't implemented or doesn't work very well. I'm actually collaborating with the Vagrant team to make some improvements to Vagrant package so that hopefully when this comes out, there will be kind of some updates to Vagrant as well that will help the two of them mesh better with each other. But in the meantime, what it means is that there are some providers which you can't neatly package back up into a box file. So again, if you want to start from a Vagrant box and then finish with a VMDK or VMX or something like that, your best bet is probably still to just unzip the Vagrant box and use the file inside. So this demo is pretty much wrapped up now. We finished packaging the box, and you can see here that the output is in testdir package.box. Now package.box is the default name. You can modify that using Packer rather than having to mess with Vagrant files. I just didn't show it in this. Anyway, like I mentioned, for those of you who want to end with a different format, I just want to point out that it's pretty easy to unzip a package, a Vagrant box. Inside the Vagrant box, you'll just find a Vagrant file and the VM files for whatever your provider was. Those providers match up fairly okay with Packer builders. So if you want to start from a Vagrant box and end with a VMDK, just unzip it and then run the VMware builder. It's pretty easy to customize. It's pretty easy to crack it open and get your files out. Anyway, I hope you try this out with the next release and give me some feedback. With that, I'm going to go ahead and wrap this talk up. That's all I've got for you. And I think I'm going to open it up for the last 4 minutes here for some Q&A. So thanks for listening. I see that there's, yeah, let me stop my screen share.
Yeah, it looks like you've got a few questions in the Q&A and then a comment in the...
Yeah, so I've got the comment. Let me open up the Q&A first. Okay, any plans for Packer to handle sysprep and shutdown of Windows images consistently on non-cloud builders? Windows is kind of a fun beast. So the answer is there's no plan to make a focused initiative, but if you're having a particular problem and you see a way that it could be made more consistent, please open an issue on GitHub, and I'd like to look into it. Windows prep can be kind of a pain for a lot of people because of the way the auto unattend XMLs work. I know you mentioned non-cloud builders. I can say cloud builders all have different ways they want you to pass it to, and the non-cloud builders, I thought all worked okay, so I would love to see an issue opened on that if that's not the case. And then I'm looking at the comments. Would I be sharing the repository? I did share that in that original slide. If you go to my GitHub, here, let me just grab the link for you out of my files, and I will save this for you on, I'll paste it into the chat for you in just a second here. I've got a repo. It doesn't have the Vagrant builders or the show local demos, but it has everything else in it. And I'll go ahead and share some of those demos. The other demos, I'll add to the repo in a few minutes. So here's the repo of everything from the talk in the chat there.